you to everyone at ETP for the invitation to speak today. I think Sarah's kindly offered to run my slides for me, so hopefully you can see them okay as well. My name is Dave Bould. I'm lead R&D specialist for Ørsted Offshore, where I look after our research collaborations with universities and other research organisations. So mostly today I'm going to be speaking to you about offshore wind energy, the part of the company that I work in mostly. We work in a really rapidly expanding sector. There's a lot of competition for highly skilled young career researchers. So I guess my main goal today is to try and persuade you that offshore wind is an exciting place to be, that we have years of interesting challenges ahead of us, that there are lots of great opportunities available to you. And I guess even more than that you should consider applying to Ørsted when you graduate as well. So yeah, this is a good slide. I think firstly, just in case you don't know us, I'll introduce you to Ørsted a bit. So I've been in Denmark for around a year and a half now, and I still haven't quite perfected how to pronounce that name. It's something like Ørsted, I think, with what we call a soft E at the end. But then outside of Denmark, I think we've pretty much settled on Ørsted, and we'll stick to that today. So we aspire to be the world's first green energy major. So that's to say a company on the same scale as the oil majors, but dealing exclusively in green energy, renewable energy. And as part of that journey, we do everything we can to influence and push the energy systems of the world towards decarbonisation and working entirely off sustainable, environmentally friendly energy sources. And if I could have the next slide, please. So we've gone through a lot of restructuring in recent years, I guess, and we've now settled into an arrangement where we have three what we call business units. And in total, we have around or just over 6,000 employees. So our largest our largest business unit is offshore. That's where I'm based, and it's around half of our total workforce are based there as well. It's this business unit that we construct, own and operate our offshore wind farms. We've got nearly 10 gigawatts of capacity, either operational or under construction, and we're the world leader in offshore wind in terms of installed capacity. So we fully intend to keep that position, and we aim to have another 5 gigawatts installed within the next 5 years across Europe, Asia and the US. We have an onshore business unit, which manages all of our fleet of onshore wind and solar plants entirely in the US. To date, much of our work there is much of our energy storage work is in the offshore business unit, but it's obviously very relevant for offshore now as well. We're kind of bringing that over to the offshore business unit gradually. And finally, we've got our bioenergy and markets business unit, which is entirely based in Denmark. So it's here that we deal with our large corporate power customers, conduct our market trading operations, and we also manage the conversion of our previous coal power plants in Denmark to biomass. And that process should be completed by 2023, at which point I think we can say we're genuinely a green energy company by then. We also until recently had domestic electricity customers, but we've just sold that part of the business out to Seas MEE. So I think almost entirely what I'll talk to you about for the rest of this presentation is offshore wind operations. And if we can hop over onto the next slide, please. So for, I guess, just about over a decade now, we've been on a very rapid transition from being a black energy company, so a company based around fossil fuel operations. We were called Dong Energy previously, to what will soon be an entirely green energy company called Ørsted. So we began that process in 2006, but it really picked up pace, I guess, over the last 3 years. So in that time, we've more than trebled our green energy capacity, and at the same time retired a lot of our non-green energy capacity. We've reduced our CO2 emissions by almost 93%, and at the same time increased our profits by around 20% per annum. So what we're hoping to show here is that the business models for fossil fuels are now truly outdated, and that it's perfectly possible to rapidly shift to green energy while preserving and even improving your financial performance. So I guess from our perspective, there's now really no excuse for not making this change to a green energy future. And if we could hop to the next slide, please. So I guess, of course, sustainability isn't just about carbon emissions like we saw on the previous slide. And in terms of corporate responsibility, we're determined to continue improving all aspects of our sustainability practices. We were recently named the most sustainable company in the world by the Corporate Knights Index. That's something we're really proud of, and we're determined to maintain that next year and future years. The way we hope to do that is we're currently targeting at entirely decarbonising our own operations by 2025. And by 2040, we want to have pushed our supply chain to also have entirely decarbonised. So that's really about using our position in the market to put pressure on the entire industry to become more sustainable and make sure that the power we sell can be considered as, at least as close to truly carbon neutral as possible. And on the next slide. So yeah, this slide is really all about the scale of what we've done over the last couple of decades, really. So offshore wind's now often considered a massive success story, I suppose, of innovation and technology development and market development as well. So broadly, you could say much of the success of the sector can be attributed to becoming really truly cost competitive. And that's been achieved in a very short space of time by rapidly increasing the scale of what we do. So at Ørsted, or Dong Energy at the time, we installed the world's first offshore wind farm at Ørsted in Denmark in '91. That was 11 450 kilowatt turbines. And for comparison, the next arrays we install in the US will use 12 megawatt turbines from GE and have total array capacities well over 1 gigawatt. So a single one of these new turbines will install has a scale many times the entire array capacity of Ørsted. So I think basically through a combination of larger turbines, larger arrays, better installation and maintenance techniques, and a variety of other factors, the cost of energy offered by offshore wind has reduced massively in recent years. We can see a bit more of that on the next slide. So this gives us a time frame of about 7 years. So between 2012 and 2019, the average levelized cost of energy that newly established offshore wind farms could offer was 167 euros per megawatt hour. Back then, that was a drop to a drop of this scale, so say to 56 euros per megawatt hour. That was considered really ambitious, and actually we've easily made that. That current price of 56 euros per megawatt hour is actually perhaps slightly conservative, and the arrays we'll see in the next 5 years will beat that by some distance again. So all that's brought us really rapidly to a position where we're more than cost competitive with generation from coal and gas, for instance. And you can see on this slide that nuclear doesn't even really begin to compare in a cost comparison. So again, that's largely been thanks to innovation and R&D targeted at really very quickly increasing the scale of what we do. And on the next slide. So I think, at least to my mind, that really frames offshore wind as a huge success story in the transition to green energy. And then the question is, do we really need to keep focusing on R&D, or should we settle into some kind of routine of business as usual and be, comfortable and confident that we've done enough to have our place in the energy system? And I think the answer to that is clearly and emphatically that R&D is more important now than it ever has been, really. That's largely a result of offshore wind coming to play an ever more significant role in our energy systems. So we envision that the setting for offshore wind will continue to evolve very rapidly in the next decade, up to 2030. We've got radical changes in the markets we work in and the energy systems that we're part of. We're looking at ever tougher environmental restrictions. We're looking to do everything at much, much bigger scale, and we'd have to keep being cost competitive regardless of what our competitors do. So the next few slides are really delving into a few of the challenges that we see that we're going to have to deal with before 2030. So on this slide, you could say that offshore wind's been pretty much a European exercise until now. In fact, it's been quite confined to just a few European countries, particularly the UK, Germany, and Denmark. But that's changing really rapidly now. There's a lot of governments around the world are waking up to the idea that offshore wind can provide great amounts of low-cost green energy and help them meet their energy and climate targets. So we're already seeing a great push in many countries to, well, let's say the US and the Asian countries in particular, they're really pushing to get offshore wind installed. And a lot more countries on top of that have already signalled that that's their intent running up to 2030 as well. So that provides us a great opportunity, but also a huge challenge, I guess. We know how to develop high quality, low cost offshore wind using established and experienced supply chains in Europe. But now we have to think more about how do we do that in new markets, providing sufficient local content, but maintain the standards that we're used to. So there's a lot of work to be done there around standardization and modularization and making sure that we can build assets to the same standards no matter where we are in the world and who we're working with. And then we see the bottom point here is one of the real hot topics at the moment is floating wind. And we don't currently see that floating offshore wind provides a particularly strong commercial opportunity. And indeed, there's no real shortage of fixed bottom opportunities for us to pursue. But it's certainly not far away from becoming an attractive opportunity. And by 2030, I really expect there to be commercially viable options, and particularly in countries where fixed bottom isn't viable due to the offshore situation. And on the next slide, we've got a few details of how we see the energy systems that we integrate with changing. And this is really just a continuation of a strong trend that we're already seeing, that conventional generation is being phased out in favour of renewables, and renewables are assuming more and more of a responsibility for stabilising and balancing the electrical grids. So that demands that we continue to develop the suite of ancillary services that we provide to grid operators, and we're talking about things like frequency response, black start, inertia, that kind of thing, things that were previously the reserve of conventional generation like coal and gas. I think we fully expect that much of our export capacity will start to go through some form of integrated energy storage before delivery to grid, whether that's battery storage or power to X, hydrogen, for instance. And we see that the grids are becoming ever more complex, and stable operation of them is becoming more and more difficult. So again, we see that full digitalization of the entire energy system is going to be required for effective management of it, as partly the idea of smart grids, and then how we as green energy operators interact with those grids. On to the next slide, please. Yeah, okay. And I guess we can say, we generate green energy, and we can be proud of that. But we certainly can't say that what we do has no environmental impact. As we discussed earlier, we know there are still many things we can do to improve our sustainability. And we've got our targets for 2025 and 2040 in that field. I think the importance of doing that is becoming more and more apparent all the time. We're a heavy manufacturing industry, and we know we can still make significant improvements in the energy efficiency, for instance, of the manufacturing, and that we really need to reduce our dependence on scarce and hazardous materials, for instance, in making generators. We can't certainly claim that installing our arrays doesn't have some environmental impact either. So we have to continue working on reducing that impact. So a good example there is the new technologies we look at to reduce the noise that we generate when we drive monopiles into the seabed, or perhaps the technologies we're looking at to reduce emissions from our installation and operations vessels. We design our wind farms to last for 25 years or so, or more even. But we then have a responsibility to decommission them, to remove what we've installed, and to do that in an environmentally sensitive way. So generally speaking, you could say that if we can install them, we can pull them out again, and to some degree that's perfectly true. But I think we still have a lot of work to refine that process. Particularly, we can see that recycling of some of our components is a real challenge. Looking at the composites that are used in wind turbine blades, for instance. We can also see really ambitious government targets for offshore wind deployment. So there's some talk in Europe now that we might see up to 450 gigawatts deployed by 2050. And that's a massive increase from the 22 or so gigawatts we have today in Europe. And crazy as it seems, we might simply not have the space to do that unless we can come up with better ways of cohabiting and coexisting with other uses of the sea, such as fisheries and transport. The next slide, please. So there are a lot of stories bumping around of very significant leaders in the offshore wind industry over the years, predicting that turbines will never go above 2 megawatts, say, or will never install a monopile in more than 25 meters of water. And all of those predictions have invariably proven to be entirely wrong. And I think most people with any sense nowadays would completely avoid making those kinds of predictions. I think we could actually say exactly the opposite of what was predicted, but scale, volume, and learning, that's what's brought the offshore wind sector to being the success that it is now. And I think it's really only continued increases like that that will deliver the extra tens and hundreds of gigawatts that we need to see. Obviously, that's engineering on a massive scale, and that's a massive challenge, and we need to be sure that we improve and enforce our standards for that and leverage the new digital techniques wherever that's possible. But I think overall you could say that 12 megawatt turbines, gigawatt scale arrays, 40-meter water depths, that's nothing compared to what we'll be looking at in 2030. And then I think our final set of challenges on the next slide is all about cost. And that always has been and it always will be probably the most important factor in determining how successful offshore wind is in capturing a role in the energy systems. So we become more than competitive with conventional generation, but we've done that with the help of really quite significant government subsidies in most of our existing markets. Those subsidies are disappearing really quickly. We need to adapt to selling our outputs with no guarantee of price. So where our goal was once to outcompete fossil fuels, our competition is very much now coming from alternative renewable sources. So, for instance, solar and onshore wind. And all of these sectors have also become very cost competitive and very good at driving down costs continually. And we just need to all keep following that same path and make sure that we, in combination, remain competitive as well. And we really need to keep focusing on improving the investment case for large-scale offshore wind as well. So the assets we build are really, really expensive. They're far more than we can afford to build on our own. And that means we need to attract investment from the likes of pension funds who are really quite risk averse. And we need to make sure that we're putting forward a strong risk profile that attracts them to invest in us.
That's 5 minutes, David.
Okay, thank you. Yeah, and the next slide, please. Yeah, and this is just to say that how we tackle those challenges at Ørsted is to look at the technology needs that we imagine we'll have in the next 5 to 10 years. And there we're looking at the wind resource, the wave environment. We're looking at how we design our substructures. We're looking at the technologies we use to export the power. We're looking at the turbines that we operate, making sure we can keep them going for 25 years. We look at the methods we have for installing and decommissioning much larger and heavier structures than we're used to. And we look at making sure that we continually understand the environment we operate in and reduce the impact on it. And next slide, please. Yeah, so I guess my hope is that a lot of you might have already been considering that career in offshore wind would suit you, and I can certainly only recommend it. So it's, like I say, a sector that's growing really quickly and perhaps quicker than we really know how to deal with. And we already have a huge demand for talented engineers, particularly early career engineers. I would say don't worry if you can't immediately see where your background might fit into the needs of the sector. There are a huge number of roles available. It's even a bewildering number of roles available. And I'll try to give you just a very brief feel of some of them now. So if we look at a couple of the more traditional roles, you could say that an offshore wind operator should construct and operate offshore wind farms. This is an organogram of a typical offshore construction team. For instance, that we use on our Hornsea 2 array that we're constructing near Yorkshire. And it's several hundred people in a huge variety of roles, and we need specialists in project management and procurement and HSE, and turbines and foundations and substations, and the list just goes on and on. And similarly, once the construction team's completed their task and hands over to an operations team and a maintenance team for the next 25 years, again, we need a huge number of specialists in HSE and operations and servicing and planning and scheduling and contracting. And then that's just the construction and operations side of things. It's really just the tip of the iceberg. So the number of jobs needed to support those two construction and operations teams is huge. So we also need commercial and asset managers and IT and data specialists and contracts and legal support and environments and consent specialists. And the list goes on and on and on. So I'd be really tempted to bet that every single person in this session today could find a role that would suit them in an offshore wind developer. So at Ørsted, we either operate or we're constructing or we're planning to construct 40 offshore wind farms, and already that requires 2,500 staff. And 40 wind farms is nothing compared to what we'll be seeing in the next 5 or 10 years. And I think onto my final slide. Yeah. So Stephen Mark asked me, like, what would my one piece of advice be to early career engineers when you're considering what your career paths could be or should be? And for me, it's a simple piece of advice, but it's not very easy to follow, I admit. And it's simply, don't worry about it, don't stress about it if you don't have a clear idea of where you want to be headed. So some people have that focus and that vision and they make it happen, and that's great, but it's certainly not crucial. So I know people who said when they were 5 years old that they wanted to be doctors, and 30-something years later they are doctors, and that's amazing. But then when I started thinking about careers, offshore wind didn't even exist. When I first left university and got my first real job, offshore wind still wasn't a particularly realistic thing to want to be involved in. So I'd say I and almost everyone I work with in offshore wind, we never imagined a decade or two ago that we would end up in this sector. We've all taken the option of being a bit opportunistic, you could say, about our careers, not worrying too much about what comes in 5 or 10 years' time, just taking the next interesting assignment that helps you develop in some way and see where it leads you. It's definitely a slightly riskier strategy, but can also be a higher reward strategy, I guess. And I try and take a bit of comfort that my entirely unplanned career path has in some way mirrored the very carefully strategized career path that Dong and Ørsted chose to take. So back in 2006, I was taking my first job in the oil and gas sector. I stayed there for 7 years. And back then, Dong Energy was yet to significantly invest in offshore wind in any way, or to rebrand as Ørsted. They still very much heavily relied on oil and gas production for income. And then by 2020, I think we both ended up in the exact same place, really. We've left oil and gas behind us entirely, and to be honest, we quite often try not to tell anyone about that part of our history anymore. And I think both I and the company are absolutely certain now that that's somewhere where it's worth investing career effort. So yeah, that's my one piece of advice. I think it's it's simple. It's take it easy. You don't have to decide what you'll do for the next 40 years. So get out there, try a few things, see what you enjoy, and see where it leads you. But I definitely recommend that offshore wind is one of the things you try, and ideally that Ørsted is one of the things you try as well.
Okay, thank you very much, David, for that. Yes, I will echo that.